the daily space weather. Is it safe to come out of the bunker yet?
Oh my God. Space weather, it's pretty serious. However, if it's causing you to enter a bunker, it may not be being done correctly. Thanks for tuning in, by the way, to the Daily Space Weather. Here at the Smash News Network, least busted name in news. We do take it seriously, although we do poke at fun at space weather miscreants. This is the past 24 hours, featuring a bunch of filaments, especially in the southern hemisphere, an M-class flare, a solar proton event, and lots more. We'll even talk about the history of the gaseous sun. Let's take a brief look at the southwestern limb, the location of an M-class flare. We'll show you great detail of that in our solar flares section. Here's just the southern hemisphere. Again, a lot of plasma filaments down there. The likelihood of coronal mass ejections in the next 24 hours is nearly 100%, so we'll be covering that as well. There have been a few rather spectacular CMEs, coronal mass ejections, in the past 24 hours, which we will cover a little bit later in the video as well. Here's the eastern limb. We've got one new sunspot that just rose there to the southeast of the Earth scale. The active region that rose in the northern hemisphere, not yet a sunspot. We are expecting another one to show up soon in the southern hemisphere and possibly also in the northern hemisphere. Once again, there is the western limb. And let's take a look at sunspots here briefly before we cover some more space weather stats. So the situation for sunspots is that there are a lot of them, a whole lot of them. And there are now more than there were yesterday, as a new magnetically complex sunspot group just rose in the southeast. Here's a colorized magnetogram. These SDO browse data images depict yesterday plus today. So that is July 9th and July 10th to date. We're also seeing some impressive growth down here in these southern groups. So we've got a very high likelihood of large solar flares in both the southwestern and southeastern limbs. So that's some exciting stuff, I would say, wouldn't you? Let us know in the comments what you think. And by the way, if you haven't checked out the links below the video, check out the links in the description. One of the links you'll find down there is to our Redbubble shop. Today's featured product is a public service message brought to you at massive personal risk and expense by Smash staff and I. Please do not pole vault the caldera. You may be watching certain content on the internet that makes you really feel like pole vaulting the caldera, but don't do so, because why? Our finest days lie ahead, folks. Our finest days lie ahead. If you thought the world is ending, sorry, not happening. Most people prefer the world not to end, civilization not to crumble, and most people prefer to behave as glue, holding civilization together. So if you're going through hell, keep going. Our finest days lie ahead, and don't pole vault the caldera. Do pick up some merch, thanks to the people who did yesterday. People picked up some Universum Liberate merch yesterday. So help out with the channel. Help to support the channel financially by picking up some products, as well as advertise the channel out in public. It's a great design. Do not pole vault the caldera. It could be unhealthful. Speaking of calderae, let's see what's going on in terms of volcanic eruptions. And indeed, magma may start to become lava on the Icelandic peninsula. Yeah. So Iceland is about to likely have another volcanic eruption here. There has been a 5+ magnitude quake, which we'll cover here in the next section. And yeah, the southwestern portion of Iceland expecting some magma to pop through the surface at any moment, as it's probably located at less than 1 kilometer depth. So some activity expected to be starting at any moment in Iceland. And somebody even caught a 5.3 magnitude earthquake on camera. So here's that 5.3 magnitude quake. There you go. Great view of a quake there on Twitter from Duncan. Shaksper, Shaksper, Shaksper on Twitter. So the number of earthquakes has slowed, but we've been seeing larger quakes. So again, we'll get to that here in a minute. Fagradalsfjall, an eruption now highly likely within hours or a few days. We've also got, well, that's the same thing, the Reykjanes Peninsula. And the read more link does not work. So anyway, likely eruption on Iceland. Abiko also erupting there on Paramushir Island, producing a 10,000-foot ash plume, flight level 100. Flight level 100 from Mayan over the Philippines. Also Karengatang, producing an 8,000-foot plume of volcanic ash. Please do not pole vault that caldera either. It's located on Siau Island, Indonesia. Popocatépetl exploding as well, flight level 220. It's a 22,000-foot ash plume, 23,000-foot ash plume over Sabancaya. And here is the global seismicity map. A little bit of an uptick since yesterday in earthquake activity. A lot more quakes to cover than yesterday's daily space weather video. Here are the quakes of a 5 or greater magnitude. 5.3 at the Volcano Islands of Japan there at 1338 Universal Time. Yesterday afternoon on July 9th. Also a 5.4 near Bande Aceh. That was at 1409 yesterday afternoon. So only about a half an hour later there, a 5.3 at Japan, and then a 5.4 at Bande Aceh. Chile also had a 5.6. So there's a seismic uptick on the opposite side of the Pacific there. That 5.6 at Chile was at over 100 kilometers depth. Time was 1711 Universal Time yesterday afternoon. Then Vanuatu had a 5.3. And then the Volcano Islands had a 5.1. Those were at 1843 and 1849. So significant seismic uptick here. And here is a 5.1 at Iceland. That was at 22:22 Universal Time yesterday evening. And then at 23:02, Kermadec Islands had a 5.0. So a lot more quakes here on the list than the past few days. Big seismic uptick. And how about if we get back to space? Here's the past 24 hours from SDO, 171 angstroms, the house favorite wavelength. Again, that active region in the northeast, not a sunspot yet. The new region that rose in the southeast is a sunspot. And also major growth down here in the southwestern limb. That now becoming the most likely place to produce a large major solar flare. And let's take a look at some more wavelengths here. But first, some stats. The 10.7 centimeter radio flux now at 179 solar flux units. So that's actually another support level, folks. 180 solar flux units is another support level. So check it out right here. You can see there's a peak at 180. There's a peak at 178. There's a peak, two peaks actually at 181. So right at another breakout point here, the 180 solar flux units level. So at 179 solar flux units, that is the current situation. And let's move on to the NOAA Space Weather Enthusiasts station. So here's a Space Weather Enthusiast dashboard. No geomagnetic storms or geomagnetic unrest forecasted. So let's move on to check out Earth's magnetic moment for the past 4 hours. There you go. It's Earth's magnetic moment from space. This is Earth's magnetic shield that people are talking about all the time. Pole shift enthusiasts are telling people on the internet that this is going away. Although we don't really see any indications of that, it's just pure conjecture. The past 4 hours of Earth's magnetic moment from space look perfectly fine, although it is a low-pressure environment, as the solar wind is kind of weak at the moment. We did have a minor CME impact, which we'll talk about here in a moment. First Earth magnetic moment from the ground for the past 4 hours. There is further indication that there is no pole flip occurring. probably a lot more evidence indicating that there is no pole flip occurring than there is a pole flip occurring. Geomagnetic excursions probably happen constantly. Anyway, that's the past 4 hours of Earth's magnetic moment from the ground. KP index currently at 1. KP1 is the global average of geomagnetism. It's calm conditions. And looking at the real-time solar wind, there was a little CME impact here. And talk about a non-event, that is a pretty weak one indeed. So you can see right in this area here, you can see variations happening in the vertical component of the magnetic field. The phi angle shifts right here. We also see an increase in the solar wind density and a decrease in the solar wind speed. So some slower solar wind showing up there. Also cooler, as this bottom pane showing plasma temperature on the green line there. Pretty uneventful CME impact there. Just a minor density spike as measured by the Discover. Currently, solar wind being measured by the ACE, showing up at about 350 kilometers per second for the speed. Solar wind density here only 2.25 protons per cubic centimeter. And let's move on to some more solar data. Well, this is actually earthly data. There are the GOES magnetometers for the past 3 days, quite smooth there. Again, no major space weather to report on. And let's talk about the top view ecliptic plane field plot. Yeah, the top view ecliptic plane field plot. Now, you see this green blob right here. You see the way it has left the solar polar region. Yeah, that's super important. That is the floodgates being opened for solar maximum. So as long as that doesn't return, we're actually seeing some South Pole magnetism making it up there to the North Polar region now. So that's exciting stuff, as we've been waiting for the entire cycle for that North Pole coronal hole to leave the North Heliographic Pole. And don't get geographic and magnetic poles confused, folks. These are separate things. Here's our line of sight field plot, depicting the solar polar fields in green and red for north and south respectively, and the solar B field in blue, which is almost like a net of the extent to which the north and south polar fields overlap each other. And as the solar polar field reversal process occurs throughout the solar cycle, you see this get all sort of vertically oriented at solar minimum. It's horizontally oriented, the B field, which is depicted by the blue lines there. The B field is the field that goes through the magnet, this magnet being the sun that's moved to coronal holes. So there is the coronal hole situation. That is the past 4 days. And I would once again attract your attention to this coronal hole up here. This is the most important feature at the moment for solar cycle progression. You can see that green colored blob there. That is North Pole coronal hole magnetism making its way down toward mid-latitudes. So that'll represent a strengthening of the coronal holes of North Pole orientation, just as they set over the western limb. We were kind of hoping that would happen when it was facing the Earth, but hey, it'll rotate around, and we'll probably get a great view of that in about 2 weeks. So that's the coronal hole line of sight field plot. And let's take a look at coronal holes here in spectacular SDO ionized iron wavelengths. That's 211 plus 171 angstroms. And let's subtract the 171 angstroms to really bring out the coronal holes. Now, these North Pole coronal holes up here are very hard to see because there is a lot of plasma suspended up here by these active regions. Keep in mind, folks, the corona is very bumpy, so when a coronal hole rises over here, it's typically hard to see because, again, there's plasma blocking our view of that. But the polarimeters don't lie. They are indeed correct. People lie about space weather on the internet, but the polarimeters don't lie. So the next on our list of items to cover is, of course, sunspots. So that's what's going on with sunspots. We're all the way up to sunspot number 3369 will be the name of this new sunspot group down here. 3369 is the sunspot that just rose over the southeastern limb. Let's take a look at those. in the spectacular 171 angstroms wavelength. Now we're going to add the SDO HMI instruments magnetogram. So check this out. This is going to show you how the magnetic fields of the photosphere interact with the lower corona. So the lower corona is what's depicted by the gold portion, that is the 171 angstroms wavelength. And you can see the way those potential field surface source lines there are traced by that plasma as the plasma orients to those magnetic fields. I would also note the lower right-hand corner, the southwestern limb down there, major sunspot growth occurring. So we've got a very high likelihood of X-class solar flares showing up in the southwestern limb. Let's switch out the magnetogram for the SDO continuum. There are just the sunspot umbrae. That's another 24-hour SDO video. And let's subtract the 171 angstroms just to show the sunspots alone. So yes, there's an increasingly high likelihood of an X-class solar flare from the southwestern limb, which would be the lower right of your screen. We call the right side of the sun there the west, because that is where solar features set. We call the left side the east, because that's where they rise. And let's talk flares and energetic particles. We actually had an energetic particle event here for the first time in quite a while. It wasn't particularly exciting, but nonetheless. There's the ghost proton flux over the past 3 days. And again, a minor proton event there, unlikely to cause any polar radial blackouts or anything. But at least coming up off the floor with a minor SEP, a solar energetic particle event, when relativistic particles are generated and make it all the way to Earth at very, very high rates of speed. So that was likely generated by this M-class flare. Peak flux was around 0400. I think it was actually 350. So sometime around 0400 this morning was an M-class flare. It did generate a little bit of relativistic particle spike. And the background flux, you can expect that to continue to rise here because, well, multiple magnetically complex sunspot groups. So let's take a look at the last 24 hours here from SDO. Once again, here is another series of wavelengths, and we show different wavelengths to show different features. So there's 171 angstroms plus 131 angstroms. And 131 is one of the best wavelengths to view solar flares. You'll probably see that M-class flare all over people's thumbnails on YouTube today. Let's get rid of the 171 and swap it out for 94 angstroms. So there's 94 plus 131. We're going to zoom in on the equator. Here's a fantastic equatorial view for you. And there it is without me blocking part of the image. That is 94 plus 131 angstroms. And let's take an extreme close-up of that active group. There's an M-class flare there toward the end of that 24-hour video. Here we've got just 131 angstroms by itself. Here's 94 angstroms alone. And we've also included ionized helium here. So 304 angstroms is also a great wavelength through which to view flares from the SDO. We'll let that play through a second time, as that is pretty sweet. We hope you liked it. We hope you enjoy the Smash News Network Least Busted Name in News' coverage of these types of things. And we hope you visit our links. One of our paid sponsorship / affiliate links is the Hemp Lucid shop. So check that out. You can find a link below the video to that. There's also a link on our homepage. The most popular products are the CBD tinctures. Try the water soluble for faster action and shorter duration. Try the oil suspension, for example, the MCT oil suspension CBD tinctures. Those have a longer duration and a longer onset time. If you haven't checked out CBDs, perhaps check them out. They are useful for various things. Different people report different results. Let us know what kind of results you're getting if you are using the products in the comments. Thanks again to everybody who's picked up CBD products. Again, link below the video in the description to that, as we endeavor to keep these videos existent, publicly visible, and free for all to view. So help us out by visiting our affiliate links. And don't forget to follow us on Instagram. All kinds of lifestyle, fitness, and diet posts over there. If you need your daily motivation to go out and do stuff, well, Instagram is a good call. Instagram.com/smashomash, of course. And don't forget to check out the Amazon shop as well. The Amazon shop, today's featured product once again for the second day in a row, is Alexander Unziker's The Liquid Sun. You can pick it up for only $10 on Kindle, $22.96 for paperback. It's about 490 some pages. The Kindle book. And what it's talking about is Pierre-Marie Robitaille's hypothesis that the sun is not made of gaseous plasma, that stars in general are not made of gaseous plasma, but they are indeed made of condensed matter. So there are all kinds of reasons for this, and the idea that stars are made of gaseous plasma is essentially an idea from the 1850s. So if you haven't seen the channel Sky Scholar, go check that out. Check it out. 43,000 subscribers. Congratulations to Pierre-Marie and his son who run the channel, Sky Scholar. And we recommend starting out with the first video there, History of the Gaseous Sun with Dr. Robitaille. We'll play a little clip from this one. It'll be short. It'll be less than 8 seconds because we don't want to get any kind of copyright strikes or anything like that.
But rather than adopt a condensed solar surface, they thought of the photosphere as being composed of clumps of...
Anyway, Sky Scholar, check out that channel, highly recommended. And don't forget to check out our links as well. Of course, you can find our links over at the homepage at smashomash.com, the official homepage of the Smash News Network, least busted name in news. Congratulations on realizing this channel exists. Please support the channel via clicking our links, purchasing items, helping us advertise, visiting us on social media, sharing the content, etc. Thanks to everybody who has, and to everybody who has tried to hide the fact that our channel is the ultimate daily space weather. Good luck. You can't hold a good channel down. Again, welcome to the Neo-Renaissance. It's a big deal for cosmology. So, here's what's going on overhead at the moment, Lehigh Valley, Pennsylvania. We've got the Saturn, we've got Moon, we've got the Jupiter, and we've got Sun. Also, we've got the Mercury up there. Yes. That's what's going on over Lehigh Valley, Pennsylvania. If you want to make your own star chart, try skyandtelescope.org. It's what we use. And here comes your solar system forecast as we like to orient our viewers before we talk about coronal mass ejection. So here's where things are today. And we'll advance this 1 week. Here's where things will be in a week. We'll be just on the cusp of a new moon on July 17th. And here come coronal mass ejections. So this is yesterday's CME computerized interpolation. That's on the left. The plain Soho-Lasco C2 is on the right. And some pretty spectacular CMEs happening there. These do not appear to be earthly directed based on the available data. Here are today's CMEs, an additional 39 frames. And that one, out of the southwestern limb, likely does have an earthly directed component. So you can see a halo as that happens on this side over here. Less so over here, but this is just this image interpreted by computer data. The computer can see contrast a little bit better than the human eye, so you can see a halo there. likely earthly directed component there, so we can expect that to arrive sometime after midday on July 13th. So CME impact forecasted there for July 13th. Did you hear me? CME impact for planet Earth forecasted sometime after midday on July 13th. So here are some more coronagraphs. We've also included the Soho-Lasco C3 there. So there's that CME this morning. It looks like it was associated with that M-class flare. Let's just check. Yep, it came out just a couple hours after that, so likely the M-class flare was associated with that CME. Quite a good one. It is not directly oriented toward Earth. However, a significant component of that is likely to strike Earth. Let's also show the view from stereo A here. And we like to show this image daily because, well, stereo A and stereo B and the Earth are all very closely located together. As you can see there, the red dot is stereo A. And here's stereo A's coronagraph over on the left. Again, you can expect coronal mass ejections to continue here. Also pay attention to the time and date stamps. Those are not synced. So a CME impact there, likely on the 13th. Let's include some additional imagery for you here. Here are our 24-hour custom composites. That's SDO 193 angstroms, along with Soho-Lasco C2 and NC3, all synced up for your viewing pleasure. Number 1, I order you to not number 2 in your pants over this. It is not going to shut down civilization. Engage. So likely a minor CME impact. I'll say you can expect no higher than a KP 6.33. KP 6.33 is the highest likely KP index you'll see from that. Here's a little closer view. And you can see that plasma indeed emanating from this southwestern limb. Coronal mass ejection on the way. Expected to arrive sometime later in the day on July 13th. There's another view of that, and let's zoom in all the way here and show just the 193 angstroms wavelength. Probably see plasma reverberations happening there after that M-class flare. Anyway, that's what's going on. And let's move on. We don't want the video to be too lengthy. So next, let's talk filaments. Yeah, filaments. These are the things that often become coronal mass ejections. And there is the El Teide, Spain Hydrogen Alpha Telescope. There's a great filament right here that ought to get named. And by the way, the one that's headed toward Earth is part of the Alex Lifeson filament. Yeah, the Alex Lifeson filament. Part of that has blasted off this part right up here. It is now headed toward your doorstep. A modern-day coronal mass ejection. Not really that mean. Could see some aurora at mid-latitudes from that. So this filament here could certainly use a name. And by the way, we are also on Twitter, if you haven't noticed. You can find a link on the homepage to that. And if you want to name filaments after living people, follow the hashtag #NameThatFilament over there on Twitter. And here are the past couple of hours. Looks like another CME may be happening right here. Or perhaps just a filamentary collapse. But that is the past about 2.5 hours from the GOES 18 SUVI. which brings us to our bonus features segment. We used to make it a separate video. That lowered our views on YouTube, so now it's in the main space weather video. Satellite charging hazards are non-existent. Smooth sailing at the moment for satellites. No electrons building up on the outside or inside of spacecraft. The GOES electron flux here just in a moderate range. A good forecast by NOAA. Here's the one-year graph to put the electron flux in context. It is measured at the F layer of the ionosphere. Here's the forecast model. And you can see pretty close there to the forecast represented by the green boxes. The yellow diamonds are the observation. Here's the layer of the atmosphere where it is measured. And feel free to pause the video on this frame, folks. That is depicting the temperature of the different atmospheric layers, the temperature of the thermosphere at solar minimum versus solar maximum, electromagnetic radiation penetration, and also chemical concentrations at different altitudes. What we're showing next is the F layer, located at 300 kilometers of altitude. So there you have the bridge between Earth and space. Nothing major going on there. However, we show it daily on the channel just in case, because you never know when a data set will become relevant for some predictive value or some other discovery. Makes us realize that a data set is relevant when we didn't know it was relevant. Remember, correlation does not mean causation. Here's the anomalygram. That's anomaly in megahertz from a 30-day median. And again, nothing very major happening there. The ionosphere looking fairly settled at the moment. No real surprise, as it has been geomagnetically calm conditions for days. Again, that's anomaly in megahertz from a 30-day median. The vibrational frequency of the F layer. There's the latest image, 11:15 Universal Time ionogram and 11 o'clock Universal Time anomalygram. There's 11:30. Okay. If you say so. If you say so. Next, how about the electron flux? Yeah, the electron flux. Here at the Smash News Network, the Busted Name of News, we're interested in the electron flux and actually the electron content. Yeah, the electron content. So let's don't forget to show that. And we show this diagram to show distances in miles. The total electron content is the distance to your GPS satellite to your handset, a run of about 12,500 miles. And we are seeing continued anomalies here south of the Indian Ocean, the Southern Ocean, Antarctica, and south of the Atlantic Ocean. So you see a lot of electrons there out of place a little bit, mainly south of the equator, again, Southern Indian Ocean, Southern Ocean, and Antarctica. So that's actually a little bit abnormal there. Some high electron contents there in the southern hemisphere. A little bit unexpectedly high, as it is winter down there. But in any case, there is the forecast. Those are the most likely places to see GPS errors. Try turning on your Wi-Fi location accuracy. If you are navigating through some of those red blobs, that could increase your ability to successfully navigate. And here's a total electron content anomaly from the 10-day average over North America. And some high electron content anomalies there over Central America and the U.S. actually. They are all pretty minor. No freaky looking anomalies in the electron contents. We'll close out the space weather section of the video with the latest solar intensitygram and latest colorized magnetogram. There's the refresh. Do we have a sunspot up here yet? Well, the answer is no. That active region not exhibiting a sunspot yet. This new region down here is quite magnetically complex. That's capable of producing a large flare, but the most likely place to see a large flare is becoming promptly this area down here. So it's already been quite active. And that is a significant number of umbrae there in the same location. That is a lot of magnetic complexity. And we are seeing some minor deltas there. These groups up here are also approaching the limb. So don't rule out the possibility they could produce a large flare. Anyway, what we've got is a whole lot of sunspots and we're about to go over the number 200. Sunspot number is currently at 190, and with this new group, that'll push us well over 200. We'll be at about 215 sunspots or something like that. Let's see, we'll be at about 220 sunspots actually, once that new group gets counted, as it includes many umbrae. So that ends our space weather section, and thanks for tuning in. But stay tuned, because here comes the meteorology section. First thing we're doing is wave chasing. Yeah, wave chasing. The largest waves that we see in the world here are currently in the, let's see, that's the South Atlantic, I guess. That's the Southern Indian Ocean. And yeah, 34.7 foot waves down there. That is the stormiest portion of the planet right now. And this imagery depicts surface winds. That's the animation, and the gradation of color is significant wave height. So yeah, that's what's currently going on as far as waves. If you're a wave chaser like me, you may have found this interesting. Otherwise, you might not care. But it looks like some good surf likely there in the southwestern corner of Australia. Whether or not anybody lives there, I have no freaking idea, as there's too much stuff to study to worry about geography. So here are the surface winds of the eastern portion of the planet. And if you're located in this area, share the freaking videos. There are like 3 billion people in that area, so press the share button, dudes, because our channel is highly underviewed. Here are the jet streams of this side of the planet. 2 anticyclones here, one over Southeast Asia and one over the Western Pacific. Great example there of some high pressure zones. There's one. There's another one, both rotating clockwise. And that is the jet stream scenario for the East. Here's the jet stream scenario for the West, and we've got a coherent jet stream over the U.S. It's shaped like an N. That's N for Nigro, my last name. And here are the surface winds. Surface winds of the central world are looking like this. And like sands through the hourglass of time, these are the jet streams of your lives, blowing backwards over the northern and equatorial Indian Ocean and the African northern continent. How you like them apples? Not too much. Oh, you do? All right, that's good. Anyway, here's a great satellite view. This is what's going on over the Atlantic and Pacific and the North American continent. We've got a south to north flow here in the northeastern U.S. and some major flooding actually occurring in New England. We'll get to it. First, clouds and fog over the Americas. So there's a pretty strong low there off the west coast of South America. You can see that clockwise rotation. Great equatorial cloud bands visible there. A normal feature of planet Earth. And there is the view of the northern portion as the sun gets lower and lower in the sky. Don't worry, Southern Hemisphere, spring is coming. Next to your weather.gov map. If your location is lit, head to weather.gov and click your location. These are too many things to cover. We've got excessive heat warnings. We've got red flag warnings. We've got flash flood warnings. Please don't travel through flowing water, especially if you don't know the depth. Weather.gov is where to get your weather alerts, and here come some forecasts. So the first thing we're covering here is the jet stream. Yeah, the jet stream. This is your jet stream forecast for the lower 48. It's the 250 millibar winds based on the GFS 72-hour model. Next, your temperature anomaly forecast in degrees Celsius. It's the same model, the GFS 72 hour. Again, temperature in degrees Celsius. It's temperature anomaly. And that's based on the 1981 to 2010 climatology, by the way. Consumer tip, don't confuse climate with weather. Climate is like a 30-year trend in temperature. Weather is all of the weather currently occurring. Completely different things. Climate and weather, if you've got them confused, it could be detrimental to stupid conversations on the internet, on social media, about the climate and the climate change, etc. Here's a 72-hour GFS pressure and precipitation forecast. And some very heavy weather there coming to Illinois. An ultra-strong low is about to form there. That's in about 2 days. So be prepared for that. That's likely to bring damaging wind, hail, possibly tornadic activity, as massively different pressures collide. Cold, dry air from Canada and warm, moist air from the south are going to mix. And that is going to create some harsh weather, especially around the Illinois-Missouri border. Again, it's a 72-hour GFS pressure and precipitation forecast. And let's continue on to show lightning. There is your NASA GOES lightning mapper. That is the past about 10 hours. Here is the real-time lightning map from lightningmaps.org. Next time you hear thunder, check it out. I pretended like I was a horror movie villain just yesterday using the lightningmaps.org map to forecast thunder. Yeah, it's a thing. So, for example, if you're northwest of Lubbock, you could forecast those thunderclaps by simply looking at this map and then saying, if you're right here, you say, pretty soon your soul will be cast into an ever-deepening and darkening abyss. And then the thunder shows up, and then you look like people think that you're Thor or something. You can frighten the natives. Or perhaps convince the natives that you're Zeus with lightningmaps.org. It's fun stuff. By the way, fun stuff is also located at smashomash.com/smashteam. If you want additional content, check us out over there. smashomash.com/smashteam, the official subscription services site of this channel. If you want additional content, become a member of the Smash Team. If you want email notifications about videos just like this one, become a member of the Smash Team. We even send them out to bronze level members. There's also a silver and a gold level membership. The best value is the gold annual paid up subscription, as it includes complimentary merch. And let's close this mother out with some additional weather facts. Facts. They're very controversial. It is 2023 after all. Here is the U.S. Doppler radar map. This is simply showing vertical motion in the water column. In the air column, which in New England is a water column. So heavy rains there showing up. We showed the forecast for this yesterday, especially Vermont there. Again, if you've got flash flood warnings, get your weather alerts from weather.gov. There is the full lower 48 view. Here is clouds and fog. And that weather is going to continue there as there is this south to north flow. So the faster this moves to the east, the better it'll be to end that flooding. That cold, dry, massive air there from Canada is providing the impulse to slowly move that slightly to the east. Here's your recap to close out this video. That's U.S. Doppler radar. Here is clouds and fog. That's 3.9 micrometer infrared radiation, and here is 6.19 micrometer infrared radiation, showing water vapor as in all of it. And it's likely clear skies over the state of Colorado, despite all the hot air coming out of that state. Anyway, speaking of Colorado and hot air, once again, we hope you have not hidden in a bunker because you're frightened of space weather and you're believing nonsense on the internet about it. Hopefully we've provided some detailed imagery and information about space weather, and hopefully you've pressed subscribe, like, share, comment, etc. In the meantime, I'm headed back to the bunker. Good luck with things, and we hope your bunker is just the right depth.
I'm going back to the bunker again. All the nonsense that I've heard encouraged me to jump in. What?